Hello everybody, welcome to my class. Today I am going to start conic section. This is an important part of class 11 syllabus. Let me start. Conic section. What is conic section? For this, we have to consider a straight line which is fixed and a fixed point. This fixed point is called focus and this fixed straight line is called directrix. Now, suppose a point P moves in the plane keeping a fixed ratio between its distances from the fixed point and from the fixed line, that is PS by PM is always constant in each and every position of its locus. Then the path traveled by the point P is called a conic. What I have said? I have said that suppose a point P moves on a plane keeping a fixed ratio between its distances from a fixed point and from a fixed straight line, then the path traveled by the point P, that is the locus of the point P, will be called a conic. This constant ratio is called eccentricity and is denoted by small e. When this ratio e is 1, that is PH by PM equals to 1, that is equal distance from the fixed point and from the fixed straight line, then the conic is a parabola. When e less than 1, then the conic is an ellipse, and when e more than 1, then the conic is a hyperbola. So let me start with the concept parabola. Conic section, parabola. First, let us find standard equation of parabola. For this, this is our x-axis, this is our y-axis. Suppose the point a comma 0 is taken as the focus and the line x plus a equals 0. Is taken as directrix. Then we will get a curve like this. In each position of the point P, PS by PM is 1 here. So then this locus is called a parabola. This is a parabola. Let us find its equation. Suppose at any position the coordinate of the point P be h, k. Now PS, that is distance of the point P from the focus S. This will be root over of h minus a whole square plus k square units. PM. What is PM? PM is perpendicular distance of the point PHK from the line x plus a. This will be mod of h plus a root over of 1 square plus 0 square units. That is mod of h plus a units. Now by definition of parabola we know PS by PM is 1. That is we can write PS square equals to PM square. I have squared both sides to remove the square root sign. So what will be PS square? PS square will be h minus a whole square plus k square equals to h plus a whole square. So we get h plus a whole square minus h minus a whole square equals to k square. So finally we get 4ah equals to k square. Therefore equation to the locus of the point ph, k, that will be 4ax equals to y square, that is y square equals to 4. This is the standard equation of a parabola having focus at the point a, 0 and directrix x plus a equals 0. Okay. Now let me introduce some basic concepts or basic parameters in case of in the discussion of conic section. First one is axis. Number 1, axis. What is axis? This was our parabola. This is focus, this is directrix. Look, the line passing through the focus and perpendicular to the directrix. The line passing through the focus and perpendicular to the directrix is defined as axis. The straight line passing through the focus and perpendicular to the directrix is defined as axis of the conic in general. Here in case of parabola, this is axis. Number 2, vertex. What is vertex? This point is called vertex. This point is called vertex. How does this point appear? The point of intersection with the axis and the curve. So, the point of intersection of the conic with the axis is defined as the vertex. In case of parabola, there is one vertex. But in case of ellipse and hyperbola, there are two vertices. Okay. Number 3, focal chord. You know what is chord? Chord is the line segment joining any 2 points lying on the conic. So that particular chord which passes through the focus, they are called focal chord. So the chords of a conic passing through the focus are called focal chords. Focal chord. Then double ordinate. One, two, three, four. Double ordinate. Look, any chord perpendicular to the axis, they are called double ordinate. Any chord of a conic perpendicular to the axis is defined as double ordinates. Next, latus rectum. What is latus rectum? That particular double ordinate which passes through the focus is defined as latus rectum. That particular double ordinate passing through the focus is called the latus rectum. Okay. These are simple concepts that we have to know. Now let us draw a bead drawing, and in that drawing I have to level out all these concepts. Suppose this is our focus is a comma 0. This is our directrix. directrix. Its equation is x plus a equals 0, and the point where it intersects the axis is minus a comma 0. This is vertex. This is our parabola. This is vertex. Which is 0, 0, where this is focus. This is directrix. This is latus rectum. LL dash. We know the equation of the parabola is y square equals to 4ax. So let us find the coordinates of L and L dash. Look, the equation to latus rectum is x equals to a, that is x minus a equals 0. So if we solve the line x minus a equals 0 with the curve y square equals to 4x, then we get the coordinates of L and L dash. So solving x minus a equals 0 and y square equals to 4ax, we get what we get? We get y square equals to 4a into a. Put x equals to a, just x minus a is 0 is x equals a. So we get 4a square. So 4a square, which gives us y equals to plus minus 2a. So the coordinate of L will be a comma 2a and L dash will be a comma minus 2a, because y is plus minus 2a when x equals a. So these are the 2 points of intersection of the parabola with the latus rectum. So the coordinates of L is a comma 2a and L dash is a comma minus 2a. So now find the length of latus rectum LL dash. Look, a comma 2a and a minus 2a, their distance will be 4a units. 4 mod a will be better, because sometimes a becomes negative. LL dash length, so 4 mod a units. Length of latus rectum. Okay. These are double ordinates. There are infinitely many double ordinates. These are all double ordinate. No, this is not. This is also double ordinate, a particular double ordinate. And these all are double ordinates. Okay? The focal chord, any focal chord, this focal chord, this is A, this is B, say. Look, any point on the parabola y square equals to 4x can be taken as 80 square comma 280. This is the parametric point on the parabola y square equals to 4x. Y square equals to 4x, its parametric point x equals to 80 square, y equals to 280. Look, if you put x equals to 80 square here, y becomes 4a square t square, so y is 280. So suppose a is 80 square comma 280. Then what will be the coordinate of the point B? Say coordinate of BB 8t1 square comma 2t1. Then what will happen? Look, these 3 points are collinear, so we can apply condition of collinearity. What is that? x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2 equals 0. Now let us consider this x1 y1, this x2 y2, this is x3 y3. So x1 is 80 square, y2 is 0, y3 is 281 plus x2 is a, x2 into y3 minus y1, y3 is 281, y3 minus y1 is 280, x3 is 81 square, x3 into y1 minus y1 is 280, y2 is 0, equals 0. Now you have to simplify it. Look, every term contains this a, so divide both sides by a. We get, what do we get? Let me write here. It becomes t square, so it becomes minus 2a t square t1. A cancel, this becomes twice a t1 minus t. Twice a t1 minus t, here it becomes 2a t1 square t. t1 square t equals 0. Again 2a is cancelled, every term contains 2a here. I mean it from here. 2a cancelled, then we have t square t1 plus t1 minus t plus t1 square t. This is minus t square t1 minus t square t1 plus t1 minus t plus t1 square t equals 0. Take tt1 common from these two. tt1, so we get t1 minus t plus t1 minus t equals 0, so we get t1 minus t into tt1 plus 1 equals 0. Look, t1 is different from t, so we get tt1 plus 1 equals 0. Obviously, write this t1 different from t, that gives tt1 equals to minus 1. This is the condition between t and t1. So, if we know one end of a focal chord, then we can find the other end of the focal chord using this condition. T1 is minus 1. Okay, this is very important condition. It will be applied in further problem. So you have to know this. Now let us have a short break. After the break, I am coming with 4 different shape of parabola. Not shape, 4 different forms of parabola. That will be, but each parabola will have axis parallel to coordinate axis. Okay. So I am coming in after the break. Till then, be there.